So this was a very interesting assignment for me because one, it has been quite a while since I've been a student in an elementary school classroom. And so I had to really dig in the back of my brain to think about um, being a learner inside of the math classroom. What I do remember is this. Um, Multiplication was taught where the teacher was standing in front of the class. She would write 0 times 0, 0 times 1, 0 times 2, and so on. We had to actually sit there and copy what she wrote, and then we had to say them to ourselves repeatedly, and then we had to write the multiplication problems on a flashcard, and then we would sit there and repetitiously go over them over and over and over and over in order. That was the biggest thing, that things were in order. And so we started at zeros one day. We studied zeros. We might have studied ones, not as long as we might have studied fives, but everything was from 0, 1, 2, 3, 4, 5, and nothing was ever mixed up. Nothing was ever really challenging, to be honest with you. At the end of the week, everybody took a time test, and the tests were pretty basic. I mean, the first test might have been zeros, ones, and twos. And yes, they were mixed up, but it was a pretty basic procedure test. A lot of my mathematics learning was outside of word problems. There wasn't a lot of connections to the real world. There was a lot of isolated learning where we sat in rows and we actually just sat there and wrote whatever the teacher wrote and did whatever she said, didn't question anything. She didn't question us. And so that was the way it was. When I start thinking about that for today's children, I'm like, whew, I don't even think I'd want my children learning that way, to be honest with you. If I had to go back today and give her advice, the first thing I would say is let's change. I would start off by advising her conceptual knowledge is a wonderful gift. Teaching children using hands-on approaches where they can actually see the math, making things come alive for them. It makes more sense to me. Actually, I have an illustration. It's very cute for the younger ages, and it also incorporates a word problem. So there's some problem solving that has to happen, but there's also some hands-on activities that the child must do in order to get to the answer, but there's still learning going on at the same time. And so it makes it interesting for the child. I think that visuals, illustrations, any kind of hands-on activity actually helps children learn better. And I think that their knowledge is retained longer. I think that's a great gift. Strategies are wonderful. Here's an example of an array. Those are some of my favorites. Arrays actually start off very young, and then they move on throughout the years. And actually, I'll show you how an array is used for algebra. And so having this strategy, teaching children this strategy very young and reinforcing it through different concepts, I think it's a wonderful gift. Strategies are great. I also think that using playtime is great for kids. So if I wanted to teach kids multiplication, I would try some playtime, especially with money, because that would be a great opportunity to double dip. And so you can actually set up a mini store maybe in your classroom with different kinds of candies. And then the children would have to choose how many candies they want. So let's pretend for a second that they wanted 3 pieces of gum and each gum costs 50 cents. Then asking the child to actually use the 50 cents, manipulating that money and creating groups. It's a wonderful idea, but they're actually playing, they're pretending, they're using money, it's real world connected, and at the same time they're still learning multiplication. I think stations are great. Anytime that a younger the younger generations can interact in stations, even the older ones. It's harder to do when they're a little bit older because then you have to teach a lot of classroom procedures, but it's well worth it at the same time. But stations are great. Kids love talking, and so trying to get kids to interact with each other about mathematics, it's wonderful because one, it teaches and reinforces the mathematics, and it also socially teaches children how to communicate, how to problem solve, how to argue nicely, and how to get along with each other. So I think that providing stations in a classroom and grouping is wonderful. I did not ever have any grouping when I was younger. I don't ever remember it throughout the course of my entire education until I hit college, to be honest with you. As far as algebra, it's kind of a copy of the elementary school years. There was a lot of procedures. Procedure. There were no explanations. It was just, here's the procedure. I'm showing you how to do the procedure. It's time for you to do it 20 times. You do it. We're going to check it. We look, kids check their work, give each other little X's and check marks, and then all of a sudden you get -2, and that's how many points you lose. I mean, I would not say it was actually very interesting at all. But let me say this. I did learn. I did understand. And so if somebody asked me today, do you know this procedure for this? I would know it. But to be honest with you, even when I started teaching, I teach 7th grade at this time, but during my earlier teaching years, I had to really sit there and go to PDs and read books because I did not know how to conceptually teach. I was always taught using a procedure. And so it was actually a challenge for me to teach children conceptually. It was a challenge for me to learn how to break things apart and to make things easier for children to learn. Thankfully, there were some great classes that I took, and so I did take them. I learned, and now I feel like I'm better at that. If I had to talk to the algebra teacher today, again, I would say stop the procedures. Everything isn't about procedures. There are great ways to teach children algebra skills through concrete representations or illustrations that I think make algebra, which is such an abstract concept, it brings it to life for children, and it makes more sense to them. So I give you an example, combining like terms, because I teach 7th grade. It's something that we actually do a lot. And so instead of starting off with x plus x or 2x plus 1y, to actually show this visualization and actually get them to group maybe the squares with the squares and the stars with the stars, and have that discussion about how many stars do we have, how many squares do we have. And these are real basic right here. They do get more complex, but it does actually help students understand simple algebra skills, and it before it becomes abstract where there's X, Y, Z, A, B, C. Now, as long as I've been teaching 7th grade, I really feel like starting off concrete has actually helped my students. I would also say be willing to slow down. It's not about how fast you go, but it is important that you make sure that your students understand. A lot of times districts give you a guideline to how long you spend on certain topics. And if your students are not getting it and you just move on, that's crazy. Because think about how basic combining like terms is. And then when you get to Algebra 1, if you don't understand that concept because the teacher thought it was a speed race, wow, the kid's totally lost. So I would tell my teacher today, I would say, hey, Be willing to slow down. It's important. I would also tell them to build an understanding, a deep understanding of the concepts, and be willing to remediate the child when it's necessary. Don't be scared to stop and sit next to the kid and actually, or even a group of kids, depending on how many kids are confused, and sit with those children and actually dig deeper into the mathematics while everybody else is moving on. There's nothing wrong with that. I think it's important that you try to remediate before the misconceptions get out of hand. I would also tell my teacher, spiral back. Go back to older concepts. If you don't use it, you're going to lose it. And so spiraling back is actually a great way to keep those fresh. I would also tell the teacher, hey, try to make as many real world connections as you can. Algebra is already very abstract. And if there is no connection to the real world, this is what the kid's thinking. Why am I learning this? Why am I learning this? And so the real world connection actually helps them understand why they are learning this. Why is it important? How does it make us better human beings? I love task and word problems, especially when you put children in groups. I'm going to say it again. I did not learn algebra in any groups. I don't remember ever discussing my learning with others or asking them questions. They never asked me questions. It was pretty much just sit and get. And so if you give kids opportunities to actually sit there and discuss word problems or try to complete tasks together, I think, again, that helps them socially because they're learning problem solving skills. They're learning how to argue with each other nicely. They're learning to communicate. I think that's a wonderful gift. And try to make things interesting. Sometimes things in algebra are just so way out there. And if you can't find a way to make it interesting by playing a game or doing a puzzle or having a little competition in your classroom, you're going to just lose your students. Especially in today's society, most of the students, they interact online. And so if you don't find a way to make things interesting, make it where they find it interesting, fun, then they're probably all going to fall asleep. And then they're going to take the state test and they're going to be lost. And so I think the more engaging your activities are, especially like playing games, kids love games. There are great online games that deal with math also. So all this sit and get stuff back in the 80s, we've got to say goodbye to that. It's time to start something fresh and new. So that's all I have to say about that. Again, thanks for listening.